Hello, I'm Maura Robie, Natural Resource Specialist at Eastern Connecticut Conservation District. Welcome to the Municipal Land Use Officials Training Series. This has been created by UConn Clear to call attention to the high-quality natural resources in the Natchaug Watershed and provide guidance and strategies to maintain it. We all live in a watershed, so this education is also useful to protect all of Connecticut watersheds. The Natchaug River Watershed is the state's largest drinking water watershed, supplying drinking water to Windham and parts of Mansfield. It includes all or part of 8 northeast Connecticut towns that are shown here, plus a very small section in Pomfret and in Hampton, but it's not labeled here. ECCD received an EPA non-point source water protection grant to start a Natchaug Watershed Advisory Board to carry out recommendations in the Natchaug Healthy Watershed Protection Plan. The focus is really on preventing pollution before it happens by balancing future development growth using land use policies and practices and educating residents and stakeholders in the watershed on ways that they can help. The Natchaug is really recognized as an overall healthy watershed due to the high amount of forest cover, which is about 75%. There's minimal development impacts and a large amount of state, town, land trust, and even privately owned protected land. In this region, residents often make a living from the land and enjoy the many recreational opportunities, such as hiking, boating, swimming, fishing, and wildlife watching. So for these reasons, it's important for towns to plan ahead for future growth in their communities. So this series of short trainings for town land use officials was developed by CLEAR for the Education for Municipal Land Use Officials work group, and it's based on recommendations that are in the plan. Brochures are also being provided on stormwater management best practices for watershed health to both land use officials and residents. So all 8 town officials have signed memorandums of understanding to work on a regional approach through the Natchaug Watershed Advisory Board's work. They are very much supporting us, and we're grateful for that. We're making great progress through the work groups and truly hope that you find these trainings useful as you do the important work of protecting your town's resources into a sustainable future. Thanks and appreciation to all for your time and dedication.
Hello, and welcome to our series of short modules about protecting our local waters designed for municipal land use officials in Connecticut. My name is Michael Dietz, and I'm a senior extension educator at the University of Connecticut, also part of the Center for Land Use Education and Research. And this series is being produced in collaboration with the Natchaug Healthy Watershed Group. So I'll have a few examples from this particular watershed in these modules. But the information that's provided here is really relevant for any watershed here in Connecticut and perhaps beyond. So let's dig into our first module here. The outline, what we'll be covering in this module are basics about what the water cycle is, what watersheds are and how they can be delineated, and then some information about how we as humans have impacted the water cycle, including both water quantity and water quality. So first, the very basics here. So it's easy to forget that this water cycle is going on around the planet at all times here. And the main things that are driving this are the energy of the sun and gravity. So we'll start on the right-hand side here. As you are likely aware, the sun causes a lot of evaporation off of our oceans around the planet and our water bodies on the land, but the majority of this planet is covered with water. So we have a lot of evaporation off the oceans. That water vapor gets up into the atmosphere. We also have water moving into the atmosphere from our land surfaces, but this is a different process. There's a combined term that's called evapotranspiration. So this is direct evaporation off of the land, but it's also water that our plant systems, our plants and trees, are pulling from the groundwater beneath the surface and moving through their systems up into the atmosphere as part of the photosynthesis process. So this is the second way that water vapor gets into the atmosphere. First, the direct evaporation off of our water bodies. Second, through evapotranspiration on the land. So the water vapor is up into the atmosphere. It condenses around dust particles and then combines into clouds and then falls as precipitation around the planet. So if you look on the left side of this image where the precipitation hits the land surface, for example, we see that water will either run off and enter a stream or river or other water body, and it can also sink down or infiltrate into the ground. This is the place where we as humans have had a dramatic impact on the water cycle, which we'll see as part of this module. So this water that then will sink into the ground, move as shallow groundwater to streams and other larger bodies of water, such as lakes and the ocean, providing base flow to our streams during times when it's not actually raining. So that is how water gets into streams, not just from surface runoff, but from water that moves slowly underground in shallow groundwater and enters those stream channels below the surface. It's called base flow. So there we have the entire cycle, and that's it's a big simplification of it, but that's the gist of how water is moving around the planet at this point. Now, to further understand the concepts that we're talking about here, we need to have a good understanding of what a watershed is. So usually if I'm in a classroom with students or other people, I'll ask people to raise their hand and say, how many of you think you live in a watershed? And I usually get a few hands go up. And my answer to that is everybody's hand should go up because we all live in a watershed. So a watershed is defined just as an area of land that drains to a single outlet. So it's not an area of water. That's a common misconception. It's an area of land that's defined topographically. And that determines where water will move when precipitation falls on that land. It also mostly determines where groundwater moves as well. So most people think that if they don't see a sign that says that they're in a public drinking water supply watershed, that they don't live in a watershed. That's another common misconception. But our public water supply watersheds are not the only watersheds out there. Just a brief touch on these. So we do have a number of large public water supply watersheds in Connecticut. So here they are in the pastel colors on this map that's provided by Connecticut DEEP. This link, all of the links actually in this presentation are combined together on a slide at the end that we will post for folks as well, because I know it's not possible to click on the link in the recording here, but those links will be made available for you. So if we zoom in on Northeast Connecticut here, as I mentioned, we're talking about the Natchaug watershed. So here it is highlighted for you there. So you can see it's a fairly large area of land that drains to Mansfield Hollow Reservoir. Now, watersheds, that one I just showed you of the Natchaug is a pretty good size one, but they can be very small. So this is an example of something I do with my students in class. I have them delineate the watershed of a catch basin in a parking lot. So we can do this the same way. It's all just defined by topography. And in this example, in this parking lot, it was just over 24,000 square feet of area that drains to this particular catch basin we were looking at. Now we can go very large. We can go to the Natchaug River Watershed as we showed before, or we can go over to the center part of our country and look at the Mississippi River Watershed. So that dark shaded area in the center of the nation drains to the Gulf of Mexico. That is a very large watershed, which is the watershed of the Mississippi River. If we go a little further west where the star is located, we can see what's called the Great Divide. This is the topographical divide in the Rocky Mountains in Colorado, which determines which way water moves. If you're on one side of that divide, water will drain to the Pacific Ocean. And if you're on the other side of that divide, water will drain to the Gulf of Mexico. So delineating a watershed, this is how it used to be done, primarily with a topographic map. So if we look at this red star down by Hanson's Pond here, for example, and we wanted to know what the area of land or the watershed that drains to that point, there's a process of moving perpendicular to topographic lines and moving across various features on the map to delineate the boundary of that watershed. So here's the watershed of that small stream. So this is a fairly challenging process to do for most people. It takes a lot of practice, a lot of trial and error. But fortunately, there are other tools that are available to do this. So the United States Geological Survey has something called stream stats, and you can basically put your address into the map and zoom in, and you can click on a point on a waterway, and the program will delineate that watershed for you. It's a little bit challenging to do this the first time through if you're not familiar with the program. On this site and also in the links that I provide at the end of the module here, there's a tutorial and some how-to guides in there that will step you through that process. But it's a very useful tool if you'd like to see some small watersheds that perhaps aren't delineated large, on a large scale like the Natchaug or other public drinking water supply watersheds. There's also a tool that EPA has that utilizes watershed information and some monitoring that's done by the states to support the efforts related to the Clean Water Act, which we'll talk about in a minute. So this tool is called How's My Waterway? If you click on that link and you can enter your address, it will bring up the watershed that's nearest that address that you put in, and it will tell you what the status of those waterways is. So you can look at each of them individually. For example, this red one, this is close to my home. I live in Ashford. So this is the Natchaug River Watershed. And there's a red segment here, which means that section was impaired for recreation. So it gives you the detail on the designated use that was tested, or the designated use that they were considering when they were doing that testing. So in this case, it was impaired for recreation, and the parameter or the cause of that was E. coli bacteria in that water. So you can read more about this. There's lots of nice information in here if you're interested. So let's move into how we have impacted our watersheds and the water cycle. So first of all, I'd like to just introduce the topic of point source pollution. So this is what most people think of when we bring up the term water pollution. This is something that smells bad or looks bad coming out of a pipe. And these are places that specific locations, factories, sewage from cities, etc., where this waste is being dumped untreated into a waterway. So until the 1970s, this was the primary cause of degraded water quality in the United States. And this is what led to things like the Cuyahoga River catching fire multiple times through the 1950s and 1960s. So these are some photos there that if you're old enough to remember this was a common thing that happened back in those days. Then because of those things that were happening, there were major events that took place and legislation that happened, namely Public Law 92-500, which is commonly known as the Water Pollution Control Amendments of 1972 or the Clean Water Act. So this legislation, although it has very lofty goals, some of them have not been met yet, but major improvements in the quality of our waters have taken place in this country as a result of the Clean Water Act. We no longer have rivers catching on fire, no longer have rivers different colors on different days, depending on what's being dyed in the mills that day. So this legislation has really had dramatic impacts on our water quality. Now, you could argue there have been other impacts on things since the 1970s. For example, this top right image is my first car. This is a 1973 Monte Carlo. Now, it's pretty tough to match the style of this automobile with our current cars that we have. Yes, that was a gas guzzler for sure, but that car had a lot of class, let's just say. And then, of course, we couldn't fail to mention 1970s fashion here, the bell bottoms, and I do like those shirts. All these things seem to be coming back into cycle, into fashion these days, so I'm kind of excited about that. All right, so if point source pollution has largely been addressed, the current challenges that we're facing are from something we call non-point source pollution. And this is namely runoff from agricultural and urban areas. These are diffuse sources of pollution that are fairly challenging to identify and control, and they are the largest sources of water quality impacts in our nation today, according to EPA. So we'll go through these individually. So first, urban runoff is the first form of non-point pollution I'd like to mention. So this is really driven by impervious surfaces like buildings, roads, and parking lots. These are surfaces that water cannot pass through and is therefore forced to run off. And in fact, engineering design has forced water to run off of these surfaces into catch basins that are a common sight in parking lots, as you see on the right. It's because in our living areas, the image on the left there is downtown Willimantic, we need to be able to drive our cars and walk to buildings and walk to our homes without going through standing water when it's raining. So there is a purpose to this engineering design, but the consequence of that is that water has been directed directly to receiving water such as streams, ponds, and local estuaries untreated. So this is a very different pathway that the water is taking now that it was not taking before this development was on the landscape. So this is a way to graphically and visually see this change that's taken place. If we consider a watershed that looks like this, something that's largely undeveloped, that we might see in this section of water or a section of river in northeast Connecticut here. And if we look at this graphically for a rainstorm that might happen over the course of several hours or a day, on the left-hand scale you see flow rate there, CFS or cubic feet per second. That green line represents the flow rate in that river over the course of time. So we'll see a fairly muted response to that rainfall event and then a gradual tailing off for a watershed that looks like this. Now, if we go for that very same rainfall event and go to a heavily developed watershed where there's a lot of pavement and a lot of infrastructure that the water cannot pass through, we see a very different response in the runoff from that watershed. So we see much more volume of water coming off of that watershed. We see a much higher peak flow rate, so it's coming off faster. And we see a shift in the timing of that water. So it's generating water at a much quicker pace than this undeveloped watershed. So all of these things have really dramatic consequences for the receiving waters downstream of these urbanized watersheds. So over time, again, this increased quantity and rate of runoff has had dramatic impacts, but there's also have been major impacts to the quality of that water. So the things that water picks up, that stormwater picks up along the way as that rainfall washes over these suburban and urban watersheds before it makes its way into that stormwater infrastructure. The various things that I'll talk about in just a second enter those waters untreated. Our larger cities and towns in the state, so cities like Hartford, New Haven, Bridgeport, have combined sewer systems. So these sometimes are subject to combined sewer overflows when we have rainfall events. So those are very problematic for our big cities. And it's not just the big cities. This is the important thing to mention here, that even these suburban watersheds, for example, 1 acre zoning lots have about 20% impervious cover. So the data show that watersheds with as low as 12% impervious cover have noticeable changes in the water quality due to human activities. So this is documented in the literature across a large range of watersheds across the country. That 12% value seems to stick out as like the point when we really see changes. And, that's not very dense development. In fact, that picture that you can see there is much more dense than 1 acre development. So 12% impervious cover is pretty sparse in my opinion, but we still see impacts as low as that. So some of the specific sources of pollutants that we see from these residential or commercial or industrial properties, all of these might be present, for example, in the Natchaug watershed or others. So fertilizers are sources of nutrients, things like nitrogen and phosphorus. Most of our fertilizers in the state now don't have phosphorus, but nitrogen is still a very important component of those fertilizers. So those things, if they're not applied appropriately, that fertilizer can run off and get into waters. Septic systems are another source of those nutrients. Pathogens such as bacteria and viruses can enter our waterways. That's sources. The specific sources here are pet waste. So if people aren't collecting their pet waste and it washes off either into stormwater pipes or directly into rivers, and septic systems as well, if they are not functioning properly, can cause excess bacteria and viruses to get into waterways. Sediment is another issue. So construction sites, if they don't have the proper erosion and sediment controls in place, the large amounts of sediment can leave these sites during runoff events. And if towns are still using road sand as part of winter de-icing, that can also enter our waterways. Other things that are potentially used on either residential or commercial properties, things like pesticides, herbicides, those can enter waterways if not used carefully or appropriately. Road salt is another important one. I'll talk about that in a second. That is obviously used by many of our municipalities, also private contractors and private properties. Many people don't realize that salt is a problem because it's a very common thing. We have it on our table at home. But if that gets into surface waters, if it gets into groundwater, it can lead to very big problems for aquatic life and for our drinking water sources. And other sources of oil and petroleum products like vehicles and other activities throughout these watersheds can be problematic. And lastly, the temperature of runoff can also cause problems. So if we're looking to conserve habitat for native trout, for example, our cold water streams in Northeast Connecticut, the temperature of that runoff is going to have a big impact on whether those trout can survive. So if we allow a large development that heats up that runoff as it moves across those paved surfaces, that's going to make it so that those trout cannot survive anymore. And removing vegetation along our riparian or streamside areas can also cause increased temperatures. So very briefly, as I mentioned, road salt is a huge issue in this state and our region. And the T2 Center at the University of Connecticut has adapted a program from New Hampshire, which is called the Green Snow Pro program. And this basically provides training for municipal public works staff on how to reduce excess road salt applications while still keeping roads safe. So they have trained a lot of municipal staff across the state. You can see the map on the bottom right. The green towns are ones where municipal staff have attended this training. So majority of towns in the state have sent folks to these trainings, and they're very valuable. There's a link that is in the resources at the end that will send you to that information there. I mentioned septic systems before. So the basics here, anything that goes from your home that leaves through a pipe first goes into a septic tank where solids are settled out. There's bacterial action in there that breaks down the volume of those solids and reduces the volume so that hopefully only liquid will be leaving that tank and then enters to the right into the subsurface disposal system, also known as the leach field. And so you really only want liquid going out into there where it moves down through the soil, and there are various processes that capture some of the pollutants in there that will basically kill some of the pathogens and viruses that might be in there, convert nitrate into other forms and filter it out of the soil so that by the time it reaches the water table, it's essentially purified. Now, if you're not maintaining that septic tank and solids start getting out into the field and clogging up the fields, that's when you can get into big problems and the system does not work as designed and can cause water quality problems. So for septic systems, the maintenance is extremely important to keep that system functioning well. And the main goal is to just keep that tank pumped out every 3 to 5 years, depending on how many people you have in the home and the size of that system. One other note that I always like to mention to people here is do not flush pharmaceutical products down the toilet. Those septic systems have no system or no treatment in place that will break down those products. So those essentially enter the groundwater and can get out into surface waters from there. Agriculture, as I mentioned, is the other large source of pollutants in this country right now. In fact, that's really the top source most years. So again, this is according to the reports to Congress that the states submit to the Environmental Protection Agency. So this is really a result of excess fertilizers, pesticides, and animal waste that run off of these areas that get into waters untreated and can lead to low oxygen, which impacts low or no oxygen in the receiving water, depending on where it's located, which can have dramatic impacts on aquatic life. And so depending on the watershed, the amount of agriculture there will determine how bad the water is draining it. In the Natchaug, for example, we have some agriculture, but it's not the dominant land use, I would say. So our water in general in this watershed is pretty good quality, although there's some areas that do have some localized impacts from agriculture. But if we look to the Mississippi River watershed, as I mentioned before, the sheer volume of agriculture that takes place in that watershed has a dramatic impact on the Gulf of Mexico, for example. So if we look at, for example, farms in the United States, here one dot is equivalent to 200 farms. So you can see that heavy concentration in the Midwest. And if we overlay that Mississippi River watershed here, as you can see, now you understand why we have those problems that I just referred to. So just getting at some of these practices here, poor grazing practices, like allowing animals to graze right up into the waterway. So there are a number of problems with that picture on the top right there, but having animals in the waterway really is not the best way to manage animals or that waterway. Other activities that take place on these large operations, these confined animal facility operations, or CAFOs, so where we have large lagoons. This is a common thing in the southeast. This is like some of the large hog farms that you maybe heard about. We have a little bit of this in Connecticut, but not an enormous quantity of those things. And lastly, improper fertilizer or pesticide applications. So the timing of that application can really have a big impact on whether that nutrient gets taken up by the plants or whether it runs off and causes problems downstream. And lastly, I will leave you with some information just about our precipitation regime. So the NOAA agency has recently updated some precipitation records. So you've probably heard these terms when you listen to the weather person on TV talking, whether if we just had a big storm that came through, they would say, oh, that's a 50-year storm or a 100-year storm. That is based on a statistical analysis of historical data, existing data for monitoring, a particular location, let's say Hartford, Connecticut. And you can do a statistical analysis on historical data to say what the probability of getting a specific event in a certain amount of time is. So for example, the older values, which were based on data from the 1930s and 1940s for Storrs, Connecticut, the 50-year 24-hour storm was 6.5 inches. The 100-year storm, 24-hour event, so the probability, so basically what that means is in a 24-hour period, the probability that we would get 7.3 inches of rain would happen only 1 in every 100 years, or a 1% chance of that happening in any given year. So that was based on the old data. NOAA updated those values given the newer precipitation totals that have been happening up until the 2010 to 2015 range. If you've lived in this region for any period of time, you are well aware that we are getting more intense storms than we used to get. And this is driven by climate change. So there's more energy in the atmosphere. This is basically causing major changes to this hydrologic cycle and causing more intense precipitation events to fall in our region. This is well documented in the literature. And because of this, NOAA has released these new values that our new 50-year and 100-year storms have increased. Our new 100-year storm is now 8.4 inches. So this has major implications. This just exacerbates all these things that I've talked to you about with our urban areas, with agriculture, and really just makes it all worse. And this also has implications for the infrastructure that's in place, such as our culverts in our towns where streams cross under roads, and the pipes that are in place in some of our municipal infrastructure as well. So this definitely has implications for our municipal operations. So to wrap it up, our drinking water supply watersheds, although very important for our public supply, are not the only watersheds in Connecticut or anywhere for that matter. Our human developments on the landscape have dramatically impacted the water cycle, including the quantity and quality of waters. And non-point sources of pollution, such as runoff from agricultural and urban areas, are the biggest concerns today. So these are the resources. We will have this slide available with live links in there for anyone that would like to get a little more information about these specific topics. And I will just leave you to look forward to our next module, number 2, which will have more specific information on low impact development or green stormwater infrastructure techniques. And that's it. I appreciate your attention and look forward to chatting with you more about these topics.